In the last video, we explored why CBCT utilization may become one of the most important economic drivers in modern imaging infrastructure. But utilization alone is not the entire story, because something else begins accumulating inside the systems over time, something potentially far more valuable than the scan itself: data. Not just images, but diagnostic patterns, workflow behavior, clinical coordination, and operational intelligence across entire referral ecosystems. And as imaging systems become increasingly interconnected, the organizations controlling these diagnostic layers may eventually control something much larger than people currently realize. Traditionally, most people viewed CBCT systems as isolated diagnostic devices. A scan is taken, a report is generated, a patient receives treatment, but digital systems are changing this model completely, because modern imaging workflows are no longer operating independently. They are increasingly becoming connected to treatment planning, implant workflows, surgical guides, cloud-based systems, AI analysis, and multi-provider collaboration. Which means the imaging layer is slowly becoming the center of a much larger operational ecosystem. And once that happens, the value of the system may no longer come only from the scan itself. Every scan generated inside a centralized imaging network creates information. Over time, these systems begin accumulating diagnostic trends, workflow patterns, referral activity, treatment behaviors, and operational data across multiple clinics. And when enough data begins concentrating into one infrastructure layer, the system itself starts becoming more intelligent. Because patterns begin emerging, operational bottlenecks become visible, workflow inefficiencies become measurable, and eventually AI systems may begin assisting diagnostic interpretation itself. At that point, the imaging center is no longer functioning simply as a radiology provider. It begins functioning as a diagnostic intelligent platform. This is one reason centralized models may become increasingly powerful over time, because fragmentation limits data concentration, but centralized infrastructure allows larger workflow visibility, higher utilization, greater interoperability, and more scalable diagnostic coordination. The more clinics connected into the system, the more valuable the operational layer may become. But there is another issue that receives far less attention: operational fragility. In many dental practices, imaging data is still managed through fragmented internal workflows. Files may pass through multiple staff members. They could be stored locally or depend on inconsistent organizational systems. And as staff turnover becomes increasingly common in dentistry, continuity begins breaking down. Scans, they become harder to locate. Workflow coordination suffers, and important diagnostic information may not always be properly backed or integrated across the systems. And this creates increasing operational stress inside the practice itself, because clinics are no longer managing only patient treatment. They are now managing complex layers of digital infrastructure and data coordination as well, which is one reason centralized imaging systems may become increasingly attractive over time, not only for efficiency, but for stability, standardization, cloud coordination, and more reliable long-term workflow management. And this dynamic already exists in many industries outside dentistry. Platforms that coordinate information flows often become significantly more valuable than the individual devices themselves. The infrastructure layer eventually becomes the strategic layer. As AI systems continue advancing, diagnostic imaging may gradually evolve from static interpretation into continuously learning workflow ecosystems, where imaging, diagnostics, clinical planning, and operational coordination, they all begin interacting together. And the organizations controlling these systems may eventually influence treatment coordination, clinical efficiency, diagnostic standardization, and large portions of digital workflow architecture across dentistry. In other words, the future value of imaging infrastructure may not come only from hardware ownership, but from controlling the diagnostic intelligence layer forming around the infrastructure itself. The future of digital dentistry may not be defined only by scanners, but by the systems connecting the scanners together. Because once data, workflows, diagnostics, and infrastructure begins converging, imaging centers may evolve into something far more strategic than most people currently imagine. I'm Dr. Robert Appel, and this is Digital Imaging Systems.